Hello students, I hope you have completed inverse trigonometric functions section B, but many of you are not asking me any doubts. This is not good. You should ask me the doubts anytime. Just WhatsApp me. So today we are going to start a new chapter, that is continuity. Continuity. What is continuity? See, continuity defines that whether a given function is continuous or not. So continuous means, suppose for an example, sine function. Consider one example, sine function, fx of sine x. So if you will draw the graph of sine x, it will look like this. So here you can see this curve. There is no breaking point. Breaking point means, suppose consider one more example, box function. So the curve of this box function is what? 1, 2, 3. So 0 to 1, the function is 0. Fx is 0 when x is element of 0 to 1. 1 should be in open interval. This thing you know, it will be 1 when x is an element of 1 to 2. 1 to 2. 2 should be in open. Then the value of fx will be 1. This will be 0. So if you plot this graph, it will look like this. Then from 1 to 2, it will look like this. And then 2 to 3, it will look like this. Again 1, 2. So here see the graph. This graph is not continuous, discontinuous. At this point, the graph has the breaking point. But sine function, or for a polynomial function, for a log function, all the graphs are continuous. But you have to show, not graphically, but you have to prove that a given function is continuous. The method is just like in limits, the existence of limit. For that, what you are doing, existence of limit, LHL, you know this thing, LHL equals to RHL. If left hand limit is equals to right hand limit, then you can say limit exists. For continuity, the main funda to find the given function is continuous or not, for continuity of a given function, you have to check LHL is equals to RHL equals to f of a. F of a means a is the point. A is the point where you have to check whether the function is continuous or not. Function, some given fx function. A given function is continuous or not at a given point a. The method is, you have to find the left hand limit, the right hand limit, and you have to check the function at that point. If all the three values were equal, then you can say the function is continuous. If it's not equal, then the function is discontinuous at the point. And some of the properties are also there. Suppose two continuous function, very important. Suppose two continuous function. This property will be applicable in later on chapters. If two functions were there, f and g, if both the functions are continuous, then the sum of these two functions will also continuous. Product of these two functions will be also continuous. Division of these two functions will be continuous, provided g of the function at that point a should not equals to 0. Because if this will be equal to 0, then it will be undefined. So these were few things. Any rational function is continuous, provided the denominator part shouldn't equal to 0. All real valued function is continuous. Polynomial function is continuous. Any polynomial function is continuous. Trigonometric function is continuous, whether it is sine, cos, tan, cosec, like this. But we will see some of the examples from the exercise. But the prime thing is, you have to remember this. For continuity of a function, What you have to check? You have to check left hand limit, right hand limit, and the value of the function at that point. These three things should be the same. If it is same, then you can say the given function is continuous. So considering some example from the exercise, see, I am taking one question, one simple question. See, question 9, fx. See, here a function is defined, fx is equals to 5 plus 3x. X is greater than or equal to 0 and 5 minus 3x for x less than 0. So that the function is continuous at x equals to 0. You have to prove that the function is continuous at x equals to 0. So the point is what? Here the value of a is the point. That is, a is here what? 0. So you have to check the function at the point 0. It is continuous. For that, the first thing is you have to find LHL. How to write LHL? See, limit x tends to, the point here is 0. So left hand limit means 0 minus f of x. In the same way, right hand limit. Right hand limit x tends to right hand. Right hand means plus. The point is, here the point to check is 0. That is 0 plus fx. Now selection of the function. See, limit x tends to 0 minus fx. Now fx is defined in two ways, when x is greater than 0 and when x is less than 0. For left hand limit, here x is 0 minus. The tendency is what? 0 minus. 0 minus is left side tendency, right? Left. So left means less than 0. So which function you will take? You will take the second one, 5 minus 3x. In the same way, right hand limit 0 plus. 0 plus means the tendency will be right of the point. So that is greater than 0. So you will take the first function here. Now simple class 11 limit. How to solve limit? See, the 0 minus and 0 plus one-sided limit. You know how to solve one-sided limit. Simple. Replace x to s tends to 0. And in place of x, you can write 0 minus x. Now limit operations. This thing, you know. Again, replace x, 0 plus is not good. Replace x with s tends to 0. And here, in place of x, you can write 0 plus h. This is the method, no? You remember this thing? Okay. Now you can directly substitute the value. 0. 0 minus 0 is what? 0. So here the value is 5, left hand limit. And again 0. So 0 into 3 is what? 0, 5. So here left hand limit and right hand limit both were same. But again you have to find f of a also. That is the function at the point. And the point is 0. 0 in 0 you have to check the function is continuous or not. So f of 0. 0 means see the equal to sign where it is defined. Equal to. Equal to is defined for the first one. So you will substitute here. You will take this function, the first function, because equal to sign is here. When x is equal to 0, then you have to select this function. So 5 plus 3 into 0. Again you will get 5. At the end you will, what you will write? The conclusion part. Here LHL is equals to RHL is equals to f of 0. Hence continuous. Like this you will do. I will take few more examples. See, which one? 15th. Suppose find the points of discontinuity of the function. See here the interesting part. Now you have to find the points. Here the given function is x square plus 6x plus 8 divided by x square minus 5x plus 6. Now you have to find the discontinuity point, the point of discontinuity. See, a given function, here the function is in rational form, no? So See, numerator will be continuous for all. You have to check the domain of the given function. To domain, so for domain, numerator is what? A polynomial function which will be continuous. I told you earlier. Here also this will be continuous, but you have to check whether for any value this function is 0 or not. If the function is 0 for any of the value of x, then the denominator will be 0 and the function will be undefined. So you have to check the domain part for this function. So for domain, x square minus 5x plus 6 should not equal to 0. This part should not equal to 0. That is x minus 3, x minus 2 should not equals to 0, and x equals to 2 and 3 should not equals to 2 and 3. So the point of discontinuity for this given function, the point of discontinuity is what? X equals to 2 and 3. So when x equals to 2, the function is not continuous because the value of fx is undefined. And when x equals to 3, again the function is discontinuous because the function is undefined. Because at 3 this will be 0. So the value of this function will be undefined. So like this you can do to find the point of discontinuity. And some other examples, see 18th. Again one function fx. See, basically the chapter is about finding limits. If you know how to deal with limit problems, then you can easily do the exercise. That's why I told you in class 11th, limits very important. It will be there in class 12. See, continuity, after this differentiability, these are the chapter where you have to use the limit operations. So here again one function is defined when x is not equal to 0, and when x equals to 0 the function is 3, so that the function is continuous at x equals to 0. Again continuity, you have to check for continuity the first part, LHL. So LHL is what? Limit x tends to, the point is 0, you have to check at 0. So left hand limit means 0 minus. Now which function you will consider? 0 minus means it is not equal to 0. So you have to exclude this second one. You have to take the first function, sin x by 3 plus 2 cos x. For RHL, limit x tends to 0 plus. Again 0 plus means not equal to 0. 0 right, the tendency of the function is right hand side. So for this, when x is not equal to 0, again you have to select sin x by x plus 2 cos x. Now simply evaluate the limits. For this limit s tends to 0, sine of, in place of x, what you will write? 0 minus h by 3 plus 2 cos 0 minus h. Limit h tends to 0. See, 0 minus h is what? Minus h, I can take minus common, so sin h by 3. Again 0 minus h, minus h, cos of minus theta is cos theta, so you can write cos h. Now substitute the value. 0, sin 0 is 0, so 0, and cos 0 is 1, so 2 into 1, that is 2. Right hand limit s tends to 0, sine of, again replace x to 0 plus h. The denominator is x. Oh, sorry, the denominator is x here. That is 0 plus h. 0 minus h, again minus h. So minus minus cancels, sin limit x tends to 0, Sin h by h is what? 1. So 1 plus 2 is 3. Sorry, the left hand limit is 3. RHL 0 plus h plus 2 cos 0 plus h. Now limit h tends to 0 sin h by h 2 cos h. This will be 1. You know the limit. And cos 0 is 1 again. 2 into 1 is 3. So left hand limit, right hand limit were same. Now you have to check at that point. Here the point is 0. So f of 0. Now which value you will consider? Because you are directly substituting value 0. So x equals to 0 is 3. You can write f of 0 is 3. Here see LHL, RHL and f of 3. All the three values are the same. Hence the function is continuous at that point. Now like this you can do. I will take some other questions. Okay, question 4th, section B, question 4. fx is defined 2x plus 1 and here 3 minus ax. X is less than equal to 2 and x is greater than 2. So here the function is defined for the value, the point 2. For less than 2, equal to 2, you can consider this, and for greater than 2, you have to take this values. For what value? Now the question is, for what value of a will function be continuous at x equals to 2? Means if the function is continuous at x equals to 2, you have to find the value of a. Now continuity part, you know this thing, LHL must be equals to RHL must be equals to f of that point, that is 2. I can write 2. So consider these three were same, then find the value of a. So for LHL, what you can write? X tends to 2 minus, which function you will consider? Less than 2. Less than 2 means 2x plus 1. So limit h tends to 0 to replace x to 2 minus h. See the method how to replace? I told you this thing in limits. Just replace x to 2 minus x plus 1. Now evaluate 0. Substitute the value at 0. 2 minus 0 is 0. 2 to 4 plus 1 5. RHL. Limit x tends to 2 plus. 2 plus means greater than 2, greater than 2. 3 minus ax. You will select this function. Again, s tends to 0. 3 minus a. You have to replace x to 2 plus h. Substitute the value 0. So 2 plus 0 is what? 2. So 3 minus a into 2. So this is RHL, this is LHL. Now the thing is, you are considered the function is continuous. So LHL must be equal to RHL. So for LHL to be equal to RHL, you can write this 3a minus 2. You can equate these two values. So from here you will have 2a minus 2, a equals to minus 1. So like this you can find the unknown value. For a equals to minus 1, now you can say if the function is continuous at x equals to 2, then a must be equal to minus 1. Like this. See, I will take one more example. Question 4th, third one. Question 4th, third one. Again, fx is equals to lambda x square plus 2. X is less than 0 and 4x plus 6. X is greater than 0. So for what value of lambda? Again the function is continuous at x equals to 0. The method is just find LHL. For LHL, limit x tends to 0 minus. 0 minus means less than 0. Which function you will take? Yes, the first one. Again evaluate it. h tends to 0, lambda, place of x you can replace 0 minus h square plus 2. Substitute the value 0, 0 square 0, that is 2 lambda. For RHL, limit x tends to 0 plus greater than 0, that is 4x plus 6. Again, limit h tends to 0, replace x to 0 plus h. Again, put the values 6. Now, if the function is continuous as per the question, then 2 lambda must be equals to 6 or lambda equals to 3. So like this you can find the value of unknown. Now one mod question, 7th first one. Fx is x minus a mod divided by x minus a for x not equal to a, and is 1 for x equal to a. What to do? Prove that the function f defined by this is discontinuous at x equals to a. This function is discontinuous at x equals to a. So let us check. So the point is a here. So left hand limit. See mod function. How to deal with mod function? Very important. Limit. The method is same. Limit x tends to the point is a. So a minus. For a minus, that is x is not equal to a. The tendency is left side. So which one you will take? X is not equal to a. So the first function, that is x minus a mod by x minus a. Now again, a minus is not good. Replace h tends to 0. So in place of x, you can write a minus h minus a mod divided by a minus h minus a. Now see, limit h tends to 0. A cancel, minus h mod, again a cancel, minus h. See limit, see minus h, mod value, mod of any negative value is again the positive one. There's a mod of minus 2, minus 2 is what? 2, mod of minus 5 is 5, just like that. H cancel, you will get minus 1. RHL, limit x tends to, see here you can say at x equals to a, the function is 1 and LHL is what? Minus 1. For continuity, all the three parts must be same. LHL, RHL and the function for that point, all the three values must be same. So here only you can give the conclusion, the answer part, that the function is discontinuous at x equals to a. But this is a mod function, that's why I am showing you how to find RHL also. So a plus, again a plus means not equal to a, so you have to take the first function. H tends to 0, so replace x to a plus h minus a mod a plus h minus a. Again a cancel, limit h tends to 0, a cancel, mod of h is h, again a cancel, h by h is 1. See the difference, here the value is minus 1 and here you are getting 1, hence the function is discontinuous at the point. Like this mod value you can treat. Now one very interesting question. Question number 11th. Fx, the function x minus 1 mod plus x plus 1 mod. Examine whether this function is continuous at x equals to 1. So you have to check whether the function is continuous at x. The point is what? 1 for 1. But see, here first you have to define this function, because there were two modes, x minus 1, x plus 1, like this. In some of the case there can be 3 mod function, 4 mod function. So the first thing, how to define, see, mod value, here the point x minus 1, see this thing, some basic, fx equals to mod x. If the function fx equals mod x is x when x is greater than 0, minus x when x is less than 0, and it is 0 when x equals to 0. So in these three cases, see this case, what you are doing, you are equating the value to 0, and then you are taking two more cases, one is greater than 0 and one is less than 0. In the same way, whenever you want to define a mod function, the first thing, whatever it is there within the mod, you first equate the value to 0, just like x minus 1. First consider x minus 1 equal to 0, that is x equals to 1. Now three cases will arise, x is greater than 1, x is less than 1, and x is equal to 1. When x is equal to 1, the function is 0, because x minus 1, you are taking x minus 1 to be 0. So mod of this will be what? 0. For x greater than 1, see, this value will be positive. For x greater than 1, consider any of the values. X greater than 1, suppose 3. So 3 minus 1 is what? 2. Mod of 2 is 2. So this value will be positive. X less than 1, this value will be negative. This value for less than, this will be negative. Consider any value which is less than 1. Suppose minus 2. So minus 2, minus 1, minus 3. To make minus 3, what you have to do? You have to introduce a minus sign. That's why this function is negative. See, the method is the points. That here the critical points were x minus 1 equal to what? 1. In the same way, x plus 1, if you equate x plus 1 to be 0, then x will be what? Minus 1. So there will be 2 points. One is minus 1 and the other one is 1. One is minus 1 and the other will be 1. You have to check the tendency. See, right side, left side, and at that point. So here you are getting 3 regions. 1, 2, 3. So if you want to define the function fx, so you can do like this. When x is less than minus 1, when x is equal to minus 1, when x is in between minus 1 and 1, when x is equal to 1, and when x is greater than 1, like this. See, I am illustrating you each and every steps. Very important case. That's why. X is less than minus 1, when x is equal to minus 1, when x is in between minus 1 and 1, when x is at 1, and when x is greater than 1. So when x is less than minus 1, see this point, you are getting this point from this function and this value from this function. So see, just you have to check the tendency, whether the region is on the left or right. See this region. When you are considering this region is left to this function and also left to this function. See, this point is for this and this point is for both the points, this region is left. So if you define this mod, you have to introduce minus sign for both the functions. When x is less than 0, left side tendency, mod of x is minus x. See, this is the method. Very nice method to remember this thing. Now, the second thing, I will do this afterwards. Minus 1 and 1, when x is in between minus 1 and 1, means the middle region. Now see, this region, for this function, it is right. And for this, it is left. The tendency is left, and here it is right. So whenever the function is left, so for this function it is left, you have to introduce minus sign, not here, here. minus x minus 1. But for this function, minus 1 point, it is right. So you should write plus x. Again, in the same way, when x is greater than 1, when x is greater than 1, this region, for both the values, this region is right. See, for minus 1 also right side, for 1 also it is right. So for both the cases, you have to take positive signs. Now at the points x equals to minus 1. So minus 1, you can directly substitute the value here. Minus 1 is what? Minus 2. Mod of minus 2 is what? 2. Minus 1, 0 plus 0. And for x equals to 1, 0. And here also 1 plus 1 is 2. So 2. But in the question, you have to examine for x equals to 1 whether the function is continuous or not. So for x equals to 1, how you can define? For 1, you are interested in 1. So there will be only 3 regions, 1, 2 and 3. So for x less than 1, for x equals to 1 and for x greater than 1. For x less than 1, the function is what? X is less than 1. See, for 1, forget about minus 1 now. For 1, the function is minus x plus x. That is 0 minus minus 2. The function is 2 here. Fx is 2. For equal to 1, again the function is 2. For greater than 1, the function is 2x. 1 cancel, the function is 2x. So you can write this also to be 2 when x is less than equal to 1, because both are having the same value. So for x less than equal to 1, it is 2, and for x greater than 1, it is 2x. Now to check. So LHL. LHL is what? Limit. The point is 1 here. So 1 minus. Which function you will take? 1 minus when less than value 2. No variable is there. You can directly write the answer will be 2. Limit. Just evaluate 2. For 2, the value will be 2. RHL greater than 1. That is limit x tends to 1 plus. 1 plus means this 2x. So limit h tends to 0, replace x to 1 plus h. See, this is the way I can directly write the answer, but this is not good. So you have to write like this: 0, again 2, and at f of 1 you have to show all the three things: LHL, RHL, and the function at that point. F of 1 is 1 equal to, when x equals to 1, that is 2. So all the three values were same, hence the function is continuous at x equals to 1. Very nice problem this one. Practice this question. One more case. See. 13th second. Very interesting. Fx is defined 3ax plus b for x greater than 1, 11 for x equal to 1, and 5ax minus 2b for x less than 1. See, the question is, if the function this is continuous at x equals to 1. It is given the function is continuous at x equals to 1. Find the values of a and b. You have to find the values of a and b. So how to do? It is given in the question that the function is continuous. Continuous means you can use the property, that is LHL equals to RHL equals to f of that point, that is f of 1. All the three cases will be same. So first find LHL. LHL means limit x tends to 1 minus. Limit x tends to 1 minus. Which function you will take? Last one, third one. X less than 1. Again 1 minus, replace 1 minus 2. H tends to 0. 5a, replace x, 1 minus h minus 2b, again 0. 1 minus 0, substitute the limit, 1 minus 0, 1. So here The result is 5a minus 2b. Now RHL. Limit x tends to 1 plus greater than 1. So 3ax plus b. Limit s tends to 0, 3a x 1 plus h plus b. Again substitute the value 0. So 1 plus 0 is 1. Here you are getting 3a plus b. And f of 1 is what? 11. If all the three will, therefore I can write 5a minus 2b equals to 3a plus b equals to 11. Because the function is continuous, so all the three values must be same. So here you can frame two equations. 5a minus 2b equals to 11 and 3a plus b equals to 11. Now you can solve for a and b. Substitute the value. So 5a minus 22 plus 6a equals to 11. 11a equals to 33, a equals to 3. Substitute the value here, b. 11 minus 3 into 3. 3, 3, 9, 11, 2. So a is 3 and b is 2. See, like this you can find the values also of the unknown. Now practice, and in many questions hints were given. So do practice, and if any doubts will be there, then please ask me. Just message me in my WhatsApp number. Thank you.